Hey there! In this video, we will explain the principle of constrained path-based testing. This technique is motivated by the drawbacks of the basic path-based testing model and also by the drawbacks of more extensive modeling notations that may be used for automated test design. To recap, the basic path-based testing model is too simple to handle a number of practical situations that may happen during the testing process. The question is, what can we add to the basic model to solve these problems? And more importantly, what can we add that will still be easy to understand and applicable for most of the test engineers? What we need to add is a simple mechanism that tells the algorithm where the test paths in the workflow must go and where they must not go. To make it simple and compact, we will achieve this by defining pairs of actions in the system under test. These pairs can force a test path to go through a defined pair of actions in the system under test, or they can prevent a test path from going through a defined pair of actions in the system. We call these pairs of actions constraints, and for this reason, the whole method is called constrained path-based testing. Of course, there might be more types of these constraints to consider, but let's keep it simple. We will talk about just two more types. When one action is executed, another particular action can be executed only once and maximally once. All four of these options we have mentioned are depicted on the left side of the slide. Later in this video, we will go through them one by one, and we will describe them in more depth. As the actions in a system under test are modeled by graph nodes, the constraints are pairs of the nodes, mathematically speaking. In the example from one of our projects shown on the right side of the slide, you can see three constraints depicted by different colors. The model is a UML activity diagram rather than a directed graph, which, for this explanation, is perfectly fine. In the same way as in the basic path-based testing model explained in the previous video, a test path, or a test scenario, is a path in the model that starts in a start node and ends in any of the end nodes. In the example on the right side, start and end nodes are highlighted with a gray background. All these test paths are part of a generated test set. This test set is computed by a specialized AI-based algorithm in the CPT manager, a tool that we are going to talk about in the next video. What is brilliant about this model is that we have just added a few pairs of nodes, so the model is still simple and easy to understand, but now, we are able to handle the problems we have discussed in previous videos. This is a very important feature. Formally, we have just extended the definition of the basic model with these pairs of nodes. Pause here if you wish to explore this in depth. Now, let's describe the four types of constraints in detail. To satisfy the positive type of constraint, node A must precede node B in at least one test path in the test set. To satisfy the once type of constraint, node A must precede node B in only one test path. To be more exact, the repeated presence of the pair of node A followed by node B in any test path violates the satisfaction of the constraint, but any other occurrences of nodes A and B in any test path that do not violate the previously mentioned restrictions are allowed. To satisfy the negative type of constraint, node A must not precede node B in any test path. Finally, to satisfy the maximally once type of constraint, node A may precede node B at most once in at most one test path. More exactly, the repeated presence of the pair of node A followed by node B in any test path violates the satisfaction of this constraint. However, any other occurrences of nodes A and B in any test path that do not violate the previously mentioned restrictions are allowed. Once and maximally once might sound more complicated, but don't worry, it's just for the sake of exactness. In principle, they are relatively simple. If you wish to dig deeper, check for the formal definitions of the constraints via the link below this video. Now it's time to talk about one important thing, which is test coverage criterion. In the constrained path-based testing problem as presented in this video, we use edge coverage. However, there is one important difference here compared to the basic path-based testing model. If certain constraints are used, it is possible that 100% edge test coverage, meaning that each edge of the graph will be visited at least once by the test paths, may not be achievable. So, the goal is to maximize the edge coverage while satisfying all defined constraints. Now, for another important point. If you overdo it with defining constraints in the model, it may happen that some may be conflicting. That typically happens if you place the positive and negative types concurrently in the parts of the model where they are in contradiction. If this happens, it may be impossible to compute the test paths because the problem will not have a solution, even theoretically. So, think before placing the constraints in the model. Let's show a few types of constraints using an example from our real-life project. During the testing process, we will decide to not test certain parts of the process in the current test round because we have tested them already. So, we place the negative type of constraint at suitable 2 nodes in the workflow, and this constraint will prevent the test paths to enter certain parts of the workflow we wish to skip in the tests. Or, we may need to test certain part of the workflow only in a lightweight way for regression test. So, we place the once type of constraint in the model at the nodes that will make test paths to enter certain part of the workflow only once. Finally, we may prefer certain part of the workflow to be tested more intensively. For this purpose, we will use the positive type of constraint. In the parts of the workflow marked by this constraint, we will make the algorithm computing the test paths to create multiple paths that explore various alternative flows in the marked section. So that's constrained path-based testing. Its model is still simple and compact, but we can handle many of practical situations that are happening in real-life project. Simply, we can tell the test paths where to go and where not to go, and that's very important to generate the test paths effectively. In the next video, we will talk about the tool, which is ready to use to model the system and to compute the test paths.